Stroke volume is important because it plays a key role in cardiac output. Cardiac output is the volume of blood moved throughout the circulatory system in 1 minute.
Cardiac output is calculated by multiplying heart rate by stroke volume. Stroke volume is measured in milliliters of blood per heartbeat. Heart rate is measured in beats per minute.
Stroke volume is the amount of blood ejected by the left ventricle of the heart in one contraction. It is measured in milliliters of blood per heartbeat. A higher stroke volume means one's heart is more efficient.
Athletes typically have higher stroke volumes and lower heart rates than untrained individuals. For every heartbeat, an athlete's heart pumps more blood than an untrained individual. Their heart rate is stronger and more adapted. Therefore, their hearts do not have to pump as fast to produce the same amount of cardiac output.
See here, the couch potato has a resting stroke volume of 71 milliliters and a stroke volume of 143 milliliters while exercising at maximum potential.
In comparison, the trained soccer player has a higher stroke volume than the average couch potato while resting and while exercising at maximum potential.
Stroke volume is regulated by end diastolic volume, mean arterial pressure, and the strength of the ventricular contraction. End diastolic volume, or EDV, is the volume of blood in the ventricles at the end of diastole. It is also known as the preload.
Mean arterial pressure is the pressure the heart must pump against to eject blood. It is also known as the afterload. The strength of ventricular contraction is the force that the heart creates with every pump. It is enhanced by the circulation of adrenaline, which includes epinephrine and norepinephrine. It is also enhanced by the direct sympathetic stimulation of the heart.
As demonstrated by the Bruce treadmill protocol, athletes have higher stroke volumes than untrained individuals. Stroke volume increases as time and intensity of the exercise increases.
As one can see, the largest increase in stroke volume for trained and untrained individuals occurs at the start of exercise. There is a smaller increase in untrained individuals at the start of exercise. Maximum stroke volume occurs at 40 to 50% of VO2 max.
In this study, athletes were able to get to the final stage of the test while untrained individuals were not. When the athletes completed the test, their average heart rate was 196 beats per minute. The untrained individuals finished the test at an average heart rate of 200 beats per minute.
Although athletes have higher stroke volumes than untrained individuals, they have lower heart rates at rest and while exercising. This is because their heart rate does not need to pump as fast to produce the same cardiac output. Trained athletes do not have to work as hard to meet the same demands.
Heart rate can be regulated with intrinsic and extrinsic regulation. Intrinsic regulation occurs within the heart. It mainly includes electrical impulses within the heart. Extrinsic regulation includes the autonomic nervous system.
Within the autonomic nervous system, sympathetic regulation will increase heart rate using cardio accelerator or epinephrine and norepinephrine. Parasympathetic regulation is a cardio decelerator and therefore slows down the heart rate. The activity of vagal tone results in production of acetylcholine.